Today I'm going to show you a pretty cool experiment to do with magnetics, okay? Magnetics are little, I don't know what you want to call them, little sticks I suppose, with magnets on each end, okay? And one is, I'm just going to call this, the black end's positive and the non-marked negative. I marked all these just now, okay? So, what I have here are two triangles made with 3 magnetic sticks and 3 steel balls. And because that each steel ball has a negative, no, this is, I call it the positive. This is the positive and the negative. This ball is neutrally charged. It has no charge at all because these two cancel each other out. So that means that other steel balls are not attracted to it. Okay? That means this right here, this is going to be the hardest. It's hardest to get this apart with just one hand. That's why it's hard. It's hard. It's stuck together really well. Okay? This is also the same. Now, I'm going to switch one of these around and show you what happens. And it's like this. This is no longer a neutrally charged triangle. One steel ball has 2 positives, so it's got a positive charge. One steel ball has 2 negative, so it is a negative charge. And one still has no charge at all. It's a neutral because it has a positive and a negative. So that means that the steel ball still isn't attracted to this end, but it's stuck on this one, and it's still attracted to this one. Okay? Now, this little nifty experiment, for this one, I'm going to need 2 triangles like that. So, it's hard to do this with one hand, so bear with me. I'm good, it zoomed out. Okay. Oh, that's not right. Now, what I'm going to do is end up putting the 2 positive ends, which repel each other. Ugh, this is not going well. One hand. The 2 positive ends, okay, they repel each other. See, they want to go negative to positive and then the positive to negative. So, what I'm going to do is I'm going to flip it over and put a negative to a neutral and a neutral to a negative. Actually, do these even have marks? Yes, they do. Okay. Sorry, I'm looking through the camera. And that means that these 2 ends will repel, and these 2 are attracted. So what do you think will happen when I put this over here? Well, you're going to find out. Look at that. It repels it so much that it's pushed right over. Right back. I'm not even doing anything. Isn't that cool? Now I'm going to cut a clip, and I'm going to have bigger triangles, so that instead of pushing it right back over, it'll actually levitate in front of it. Okay? Okay, I'm back, and I have now doubled the size of each triangle, prepared them the same way. Positive, neutral, negative, neutral, negative, positive. So when I do this, now the balls levitate. That is magnetic for you. That's a magnet. That's cool. Now, I'm going to cut to another thing I put in my room. This is downstairs at the dinner table. So I'm going to cut to my room where I should have a levitating stick in a tube. I have 5 little magnetics, okay, all with negative side up, stuck to my, I guess, must be steel desk lamp, okay, just for a common surface to make this a lot easier. They stick to, okay, and I have this clear plastic tube, no tricks or anything, it's just a clear plastic tube, and what I'm going to do is, with this magnet, make this magnet levitate. And because it's being repulsed by these, it will not come into contact, it'll levitate probably about here. Maybe a little lower. And it'll want to flip over, and then it'll be attracted to them. Okay, but because of this plastic tube, it will not be able to rotate, so it'll be levitating. So I put it in, put my finger in, and oh, gee. Okay, I'm gonna bring these closer together. Do it again. And Shazam! There you have it. Homemade levitating device. Isn't that cool? Well, I think that just about wraps it up for today's lesson in magnetics. See you next time on If You're Bored.